Hi students, this is mains 29th January 1st shift 2024 question. Question is number of compounds with one lone pair of electrons on central atom amongst the following is. Here some compounds are given. See how to answer the question to find out the number of lone pair of electrons. Look at the central atom in these compounds and find out the valence shell electrons in the central atom. If you take ozone, ozone has a 6 valence shell electrons. So if you take ozone, oxygen is surrounded by two more oxygen atoms. So six valence electrons are present in central atom, and oxygen atoms are divalent in nature, so they make two bonds. So they use two electrons. So if two electrons are used by the oxygen, suppose this oxygen is using two electrons, this oxygen is also using two electrons, then you are left with two electrons. These electrons are converted into one lone pair. So on central atom, how many lone pairs are present? One lone pair is present. Similarly, H2O, central atom is oxygen. 8 electrons are present. Hydrogen is monovalent. Hydrogen is monovalent. So out of 6 electrons here, 1 electron, 1 electron. Total 2 electrons are used for bonding. Then minus 2 electrons. You are remaining with 4 electrons. 4 electrons you convert into how many lone pairs? 2 lone pairs. So there are 2 lone pairs on oxygen of water. SF4, SF4, sulfur is a central atom. Sulfur has 6 valence electrons. Fluorine is monovalent. So 6 minus 4, 2 electrons are left over. So how many lone pairs are present? One lone pair is present. One lone pair. ClF3, chlorine, 7 valence electrons are present. Fluorine is monovalent. So 7 minus 3, 4 electrons are remaining on the central atom. That converts into 2 lone pairs. NH3, nitrogen is having 5 electrons in the valence shell. Hydrogen is monovalent. So 5 minus 3, 2 electrons remaining. That converts into 1 lone pair. BrF5, bromine 7 valence electrons. 7 minus 5, 5. That is 2 electrons. So that 2 electrons convert into 1 lone pair. HCl4, 8 valence electrons. Fluorine is monovalent. 4 electrons are used for bonding. So 8 minus 4, 4. 4 converts in 4. That 2, 4 electrons converts into 2 lone pairs. So how many compounds are there with one lone pair of electrons? It is ozone, then SF4, NH3, BrF5. So answer is 4. Hi students, this is IIT JEE 1993 question which easily you can solve. This question is related to preparation of an alkene. Kolbe electrolysis of potassium succinate gives carbon dioxide and dash. Here you have to write the main product, that is alkene product. Whenever a Kolbe electrolysis question comes and when it is given dicarboxylic acid salt, then what is the trick? Write the formula. COO minus K plus CH2, CH2, COO minus K plus. This is potassium succinate. Trick is break the bond between the COO and C. COO and C. Then after breaking the bond, the carbon which has lost the bond with COO will have one unpaired electron on its head. This CH2 also have one unpaired electron on its head. So CH2 dot, CH2 dot. Students, you know that to make one single bond, 2 electrons are required. So now these 2 electrons will join to form one more bond between the 2 carbon atoms. So what is the final product? CH2 double bond CH2, which is called as ethene, IUPAC name. Ethylene is a common name. So what is the answer? Answer is ethene. Hi students, this is mains 2025 question. This question comes in ethers. Which one of the following with HBr will give a phenol? Students, when ethers undergo acidic cleavage with HBr or HI, then you have to split this into two parts, H plus Br minus, H plus I minus. Here options are ethers. What you have to do? Due to electronegativity difference between carbon and oxygen, Carbon is less electronegative, so it will bear a positive charge. Oxygen will bear a negative charge. And here in this bond, oxygen will bear a negative charge, carbon bear a positive charge. Like this, you have to divide. Then here, this is plus, minus, plus, plus, minus, plus, minus, plus, plus, minus, plus. After doing this, you have to see how many moles of HBr is given. Here only 1 mole of HBr is given, or 1 equivalent of HBr is given. Then you have to break any one of the CO bond in the given ether. So here there are 2 CO bonds. Trick here is, when you are breaking the CO bond, see that the halide ion, whether Br minus ion or I minus ion, which is negative, it is going to attach to the positive carbon. And when that carbon is of phenyl carbon, don't attach to it. Don't attach to it. Second point is, when you break the CO bond, look at the stability of the carbocation. More stable carbocation will attach the halide ion to itself. That's it. That is the major product. He is asking you should get a phenol. Now, if I break a bond here, what happens? This is a phenyl carbocation. This is unstable. So that you should not do. Then if you break the bond here, this is methyl carbocation. But methyl carbocation is also unstable. Now, when HX reacts with the ethers, reaction goes by 2 mechanisms, SN1 or SN2. In SN1, carbocations are formed. In SN2, carbocation is not formed. Methyl carbocations are highly unstable. So don't take SN1 reaction. Phenyl and methyl carbocation both are unstable. So instead of that, think about the SN2 reaction. In SN2 reaction, phenyl group do not participate in SN2, whereas CH3 can participate in SN2. So where you have to attach your Br minus, where you have to attach the Br minus here. So Br minus you have to attach. Then where H plus will go? H plus will go this side. So here H plus will go. So what you are going to get here? You are going to get phenol. Why not the other options? Now if you break the bond here, break the bond here. So now you can break the bond here, which is more stable. This is tertiary carbocation. And this is benzyl carbocation, primary benzyl, which is more stable. Primary benzyl. So this carbocation, if you are considering, which is more stable, now attach the Br minus. Here, if you attach the Br minus, here you have to attach the H. So are you going to get phenol? No, you are not going to get phenol. You are going to get alcohol product. Now in this case, there are 2 ether linkages, COC, COC. Here also you have to break the bond. Suppose if you break the bond here, then this is a secondary carbocation, primary carbocation with some stability, resonance stability. This is a primary carbocation with resonance stability. Now, if you break the bond here, this is a methyl carbocation, which is unstable, so which is more stable. A primary carbocation with resonance stability is more stable. So now here only 1 mole of HBr is given, so only 1 HBr you have to use. Suppose if I consider the this carbocation more stable, then you have to attach the Br minus here, and here you have to attach the H plus. So this is forming what? Alcohol, not the phenol. So your answer is not this option. Then in this case, break this bond, this bond. Which carbocation is more stable? This is methyl carbocation. This is primary benzyl carbocation. Primary benzyl carbocation is more stable. That's why you have to attach the Br minus this side and H plus this side. So what you are going to get? CH3OH. But what you should get? Phenol. So that's why neither B, neither C nor D are correct. Answer is A. Thank you. Hi students. This is mains 25th June 2nd shift 2022 question on chemical bonding dipole moment. Amongst BeF2, BF3, H2O, NH3, CCl4 and HCl, the number of molecules with non-zero net dipole moment is. What he is asking? He is asking how many compounds are there whose dipole moment is not equal to 0. What is the trick? 2 points you have to remember, students. One trick is, if the central atom has lone pair or lone pairs on its head, then mu is not equal to 0. Then if the terminal atoms are same and lone pair is not present on the central atom, then dipole moment will be 0. Now, in these ones, beryllium fluoride if you take. See students, in the previous video of mine, I have shown how to calculate the number of lone pairs. In BeF2, there is no lone pair on beryllium and the terminal atoms are same here. So terminal atoms are same and no lone pair on central atom. It means this has a dipole moment is 0. So this is not your answer. BF3, boron do not have any lone pairs on its head and the terminal atoms are same. So dipole moment is 0. This is not your answer. H2O, there are two lone pairs present on the central atom of oxygen. Therefore, dipole moment is not equal to 0. So this is the correct one. NH3, nitrogen has one lone pair. Nitrogen has one lone pair on its head. So therefore, its dipole moment is not equal to 0. CCl4, the terminal atoms are same. CCl4, 4 chlorines are same and lone pair is not present on carbon. Therefore, this is not your answer. HCl, now this is a diatomic molecule and HCl bond is a polar bond. Polar bond is present, only one bond is present, that molecule is always polar in nature. So therefore, total 1, 2, 3. 3 compounds have dipole moment not equal to 0.